Okay. Now, if that is okay, now let's just do some tricky questions in the expectation. Okay, some tricky questions in the expectation. So here, like tricky in the sense that these questions are little unconventional. Unconventional means that you won't see these kind of questions too often. So let's just see these questions. Now, to solve these questions, what we will be doing, we will be using something called as law of total expectation, which is basically saying that if you have any expectation to find out, let's suppose you want to find out the expectation of x, then what you can do, you can basically say that you will break down this expectation into two parts, just like law of total probability. So basically, if you want to find out the expectation of x, then you can say that let's just say there is one event A. If A happens, then what is the expectation? Let's suppose this expectation is E1. If A doesn't happen, then what is the expectation? Let's suppose this expectation is E2. And then if I say that what is the expectation of x, E maybe, that is equal to, if A happens, then expectation. If A doesn't happen, then expectation. So if A happens, which means that the probability of A, then expectation, plus if A doesn't happen, which means E2 is the expectation if A doesn't happen, and the probability of A complement. No, these are the expectations. Even one of them could be greater than one. Okay, I mean, these are the expectations. This could be even 500. This summation need not to be one. Okay, even the single one could be anything. So here it is very different from what we have already seen as a tree method. So don't try to relate it with the tree method. Okay, here these are the expectations. So I will say that if you want to find out some expectation, then probably you need to break down this expectation into two parts. If A happens, then what is the expectation? If A doesn't happen, then what is the expectation? Let's just see the questions. So this is the question number 1, where I'm saying, if you roll a die, okay, you roll a die. If you get number which is greater than 3, you will be winning 100 rupees. Okay, you will get, right? This is you will get. Okay, if you get a number greater than 3, then you will win or you will get. Okay, so this is you will win. You will win 100 rupees. Otherwise, you lose 50 rupees. So what they're saying, that there are two possibilities. Either you win 100 rupees or you lose 50 rupees. So if you get a number that is greater than 3, so there are two events. If you get a number which is greater than 3, if you get a number which is less than or equal to 3, which means if you get a number which is 1, 2, 3, if you get a number which is 3, 4, 5, 4, 5, 6, right? If you get a number which is 1, 2, 3, if you get a number which is 4, 5, 6, there are, let's suppose, two possibilities. In one of the case, which is the first case, that you will be winning 100 rupees. So you will say that you are winning 100 rupees here. And in another case, you are losing 50 rupees, right? Now they are saying what is the expected amount of money that you win or you lose. So it means the expected amount of money they're asking, that you win or you lose. So there are two events, either this happen and this happen. Tell me, aren't these two events exhaustive? Which means that aren't these two events are partitioning the sample space? Either this will happen or this will happen, right? This is A and A complement basically. So you will say that if this happens, the probability of A is, what is the probability of the first event? Greater than 3, I think 3 by 6, because these are the three numbers, which is 1 by 2. This is also 3 by 6, which is also 1 by 2, right? Okay. Now you will say that if this first event happen, maybe this one, then the probability is 1 by 2. And in this case, you will be getting 100 rupees. If the second event happen or the first event doesn't happen, then you will be getting minus 50 rupees. So that's how you can solve this question, right? This is 50 by 2, which is 25. So E is 25 here, which means you will be winning 25 rupees on average. So can anyone tell me intuitively? Can anyone tell me intuitively what does this expectation to be 25? What does this mean to say that expectation is 25? Suppose you play this game. Then what does this mean? On average. Right? On average, this expectation means average. So on average, you will be, if you play enough number of times, then you will be getting 25 rupees. Now, suppose you play this game and you play it 10 times. Okay, you go to any club and you have a gambling, and there you play 10 times. And after 10 times, you lose all of your money, or maybe you lose, let's suppose, 500 rupees or something, right? So let's suppose you lose some rupees. Let's suppose some X amount of rupees. I mean, you are losing basically. Then you come to me and then you will say that that sir, you told me that I will, on average I will be winning 25 rupees, but I'm losing. So what will I say? Yeah. So I will just say that just go and play more games, because you might not have played enough number of games. And then you played, let's suppose you went and then you played, let's suppose 100 times. And then after 100 times also, you come to me and then you will say that sir, I lost all of my money. You told me that if you play enough number of times, then you will be winning 25 rupees, but I lost all of my rupees. Then I will say that maybe you have not played enough number of times. Okay. So basically, if you ask me that okay, I'm losing, I will just say, see, you're not playing enough number of times. Then let's suppose you play it 10,000 times. After 10 yeah, after 10,000 times you go bankrupt. Okay. So there is nothing left with you. Your house, your everything has sold away. And then you come to me, you will say that okay sir, you told me that you will be winning 25 rupees on average, but now I don't have even any house to live. Then what will I say? See, it is just 10,000. You have not played enough number of times. Maybe play more. You will be definitely be getting 25 rupees at that. So it's like that. Okay. So don't blame me. I will always say you have not played enough number of times. So don't take the inspiration from these questions. That's the moral of the story. Okay. Cool. Because whenever you ask me that sir, I'm losing, I will just say play enough number of times, because that's the definition of probability is saying just do it enough number of times and the probability will adjust for you. Okay. Now let's just solve this question. A professor occasionally employs any of the three students to do typing and such other works. Assume that Alice Alice averages 10 errors per document. So there is one student. So what is happening here? A professor assigns or employs one of the three student randomly. Okay. So if he chooses Alice, then Alice actually does 10 errors per document. Betsy does 20 errors per document, and Claire, okay, how to pronounce it? Clary, right? Okay, Claire. Okay, Claire does 50 errors per document. Okay, Claire does 50 errors per document. Suppose, okay, that is given to me, which means there is a professor. There is a professor who assigns either to Alice or to Betsy or to Claire. Right now, they are saying that that Claire does 50 errors, Alice does 20, and Betsy does, okay, Alice does I think 10, Betsy does 20, and Claire does 50 errors per document. Cool. The professor needs a document typed up, and she will give the task to whichever student shows first, which will be Alice with probability 2 by 5, Betsy with probability 2 by 5, or Claire जो भी है, with probability 1 by 5. So they are saying that the professor will assign to one of the student if the probability of choosing Alice is 2 by 5. So professor will choose Alice with 2 by 5, and here it is 2 by 5, and this is 1 by 5, right? 1 by 5. Now, what is the question? Let X be the number of errors made in the typing the document. Then what is expectation of X? Which means if Alice is given the task, he or she will make the 10 errors, Betsy will make 20 errors, Claire will make 50 errors. Now, on average, how many number of errors that you are making? Okay. So expectation of X. X is the number of errors that you have made. So it is like that. If you choose Alice, which is with this probability, then you do 10 errors. If you choose Betsy with this probability, you do 20 errors. If you choose Claire, then you do 50 errors. So if you sum this up, you will be getting 22, which means on average, you are getting 22 errors. What does this on average 22 errors means? What does this on average 22 errors means? Anyone? Just let me know. Okay. So it means that I'm saying that what does this expectation to be 22? What does this mean to say the expectation is 22? Yeah. So if you repeat this experiment again and again, which means sometimes you might choose allies, sometimes you might choose Betsy, sometimes you might choose Keller, and you do it enough number of times, which means sometimes someone is writing document, sometimes someone else is writing document, sometimes someone else is writing document, and if that has been repeated many times, then if you take the errors in all the documents, then it is 22. If you take the average of all the errors in all the documents, then it is 22. Understood? Okay, cool. So basically it is like you. Okay, please show the question. The question में कुछ नहीं है, like it is in the diagram only, like the professor is choosing one of the student and everyone is making either some error, either 10, 20 or 50, and these are the probabilities of choosing them. Okay, so my question is that if expectation is coming out to be 22, then what does this mean to say that expectation is 22? So it means that if you repeat this experiment enough number of times, which means sometimes the professor chooses allies, sometimes the professor choose Betsy, sometimes the professor choose Keller, and then if you do it enough number of times, then you will be getting how many errors? On average, you will be getting 22 errors, right? Okay. That question has been taken from UCI, which is a top university. Okay, let's do this question. This question is taken from MIT book. Okay, so what they're saying, that suppose that 49.8% of the people in the world are male and rest are female, which is more or less true. Okay, also suppose the expected height of randomly chosen male is 5 foot 11 inch. So basically if you convert that to just foot, it is 5 plus 11 by 2, 11 by 12. Okay, so that I mean, if you want to convert that inch to foots, then it will be 11 by 12. Then while the expected height of randomly chosen female is 5 plus 5 by 12. Now, what is the expected height of randomly chosen any individual? That's what they're asking. See, either you choose male or you choose female. Now they are saying, if you're choosing male, then in that case, the height will be 5 plus 11 by 2, 11 by 12. In this case, it is 5 plus 5 by 12. And what is the probability of choosing male? Can anyone tell me what is the probability of choosing male? If you choose randomly, if there are 49.8% people are there, and if you choose randomly, then what is the probability of choosing male? This is 0.498, right? And this probability is okay, 0.502. Cool. So these are the probabilities. Then how to find the expectation? So what they're saying, that either you choose male with this probability, then you will be getting this much height. If you choose female with this probability, then you will be getting this much height. So how to find the expectation? Expectation will be equal to 0.498 multiplied by 5 plus 11 by 2, 11 by 12 plus 0.502 multiplied by 5 plus 5 by 12, right? Easy question. So see here that the expectation even means that expected height if you choose the male. And what is the probability of choosing male? 0.498. So that's the formula that we are applying. Is this understood to everyone? That what we are doing? Okay. So see, sometimes it might so happen that this expectation, this even and E2 are given very directly, which means they are giving you directly that this is even. But this need not to be always the case. We will see the example. Okay, so let's just see some example where it need not to be always the case that they give you even this directly. I think in all the questions that we did here, this was given directly, right? This is 10, this is C, this is even, this is E2, this is E3, and all of them are given directly, which is 10, 20, and 50. Right? So here also 100 and minus 50. So everything is given directly, but it need not to be the case. Let's just see some question. So this is a question which is like I can say one of the quite tough question. I can say not very tough, but yeah, it is very nice question. Very like I can say interesting question. At the same time, it is little tough. Maybe a little tough or maybe more tough. I don't know. Let's just see. But this question I have taken from IIT Madras, and they have that question in their quiz. But I think that course was a master's level course. I mean, that course was, I don't know if that was undergrad or master level course, but yeah, this question is relevant for the gate. So whatever is relevant for the gate, we are picking from different sources, right? Okay, let's just read out this question. So what they're saying, two balls are drawn from a bag containing four balls numbered 1, 2, 3, 4. So there is a bag. In this bag, from this bag, you are picking two balls, okay, which is, and this is having numbers 1, 2, 3, 4. Now, if at least one of the numbers drawn is greater than 2, then you win 10 rupees. Okay, just listen here. You are bringing you are pulling two balls from here. Let's suppose both the balls are 1 and 2. Okay, then in that case you will not be winning anything. So why? Because they are saying if at least one of the number that is drawn is greater than 2, then only you will 10 rupees. Otherwise you lose the same amount, which means if both the balls are like 1 or 2, then you will be losing 10 rupees, right? Then they are saying that let X be the total amount won or lost, then what is the expected amount that you are winning or losing? So let me just go to the question again. See, what they are saying is that there is a bag. Okay, there is a bag which is having 1, 2, 3, 4. Now you pick two balls, one after another. Let's suppose you pick first ball you pick is 3. Okay, first ball you pick is 3. Now, after you pick 3, are you sure that you are going to win 10 rupees? Or do you have to pick anything else? Based on the question, they are saying if any one of them is greater than 2, then you are winning 10 rupees. Okay. So once you pick 3, you are sure that you are going to win 10 rupees, right? Cool. Now suppose instead of 3, you picked 1 as a first ball. Then are you sure you are going to lose? No, right? You will pick another ball and then you will check that, okay, are you going to lose or you are going to win? How much you will be losing if you are losing? 10 rupees. How much you are winning if you are winning? 10 rupees, right? Cool. Now let's just solve this question. So what may so happen that either you will be getting, I mean, as a first ball, either you will be getting 1 or 2, or you will be getting 3 or 4, right? Actually, I don't know the answer, so don't ask me the answer. I really don't know the answer. I mean, I don't remember. I think maybe it is in the next slide, but I don't remember. Okay, so see, when you're picking the first ball, I'm just asking the first ball. The first ball. It can be either 1, 2, or it can be 3, 4, isn't it? Or will there be any other case? Only 2 cases, right? 1, 2, 3, 4. Now, okay, if it is 1, 2. Actually, the next ball that you are going to pick can be 3, 3, 4, can be 3, 4, or can be, I mean, based on that, if it is 1, then it can be 2. If it was 2, then it can be 1, right? Okay, let's do one thing. I think this combinedly things are not that suitable for this particular case. So let's do one thing. Let me just separate it out as four cases. Okay, so which means let me just separate it out like a 4 cases. Maybe you are getting 1 at the first ball, maybe 1, maybe 2, maybe 3, maybe 4. Okay. See, I was just trying to do 1, 2 at the same time, but that was making me a little confused. So I'm just making it 1, 2, 3, 4 different possibilities. I mean, you can do any one of the thing, but that's okay. Okay. Cool. So now let's just suppose that the first ball could be anything. This is the first ball, right? First ball could be anything, which is either 1 or 2 or 3 or 4. Now, suppose Okay, Chinmay is here. Chinmay, are you someone who has secured recently a top gate rank, or you are different, Chinmay? No, you are different one. Okay, he's Chinmay Jain. Okay, he's Chinmay Jain. But the way you are answering, then I think you will be definitely get topper next year. Okay, so let's suppose that first ball you are picking is one, and then at the next ball you can either pick two or three or four, isn't it? Let me know if that is okay to everyone. Now tell me what are the probabilities here? The picking the first ball as one, what is the probability? If everything is equally likely, 1 by 4, right? 1 by 4. Now tell me what is the probability here? Will it be 1 by 4 or something else? This will be 1 by 3, right? 1 by 3. Why? Why it is 1 by 3? Because now 3 balls are left only, right? Only 3 balls are left. Cool. Okay. Now if it is 4, okay, I will cover this 2 and 3 just a second. Now if it is 4, then the next ball could be either 1 or 2 or 3, right? And what are the probabilities? 1 by 3, 1 by 3, 1 by 3. Cool. No, but I think I don't need to divide this 4. Because if it is 4, then I think I'm sure that I'm winning some rupees, which is 10 rupees, right? Okay, I will come to this. Yeah. So let's just come to this case. If it is 1, then I will be picking another ball, and based on the another ball, I will declare whether I'm winning or losing. Now tell me here how much I should write. How much I am winning or losing, or what number I should be writing. If I'm getting 1 2 edge balls, then what is that number that I should be writing here? I'm losing 10 rupees, right? So it should be minus 10. Here in this case, I'm winning or losing? I'm winning, right? It is plus 10. Here in this case, it is plus 10. Okay. Cool. Yeah, that's great. Now let's just see that in case of 4, what's going to happen? Okay. In case of 4, can I directly write plus 10 here? Can I directly write plus 10 here? Let me know. Because either it is 3 or 4, then you are winning, right? Okay. Now in case of 2, I further have to divide. I can either get 1 or can get 3 or can get 4. But because of symmetricity in the sense that I don't think there is any difference between 1 and 2, right? I mean, whatever purpose that 1 is serving for 2, I mean, vice versa, that 2 will be serving for 1. So I think the tree diagram will be same, even if I expand. So anyway, let's just do one thing. Let me write the numbers here. So see, I have divided my sample space into 4 parts. So I will say, if I get 1, then what is the probability of getting 1? This is the probability of getting 1. So maybe I can write something like this. What is the expected amount of money that I'm winning or losing if I'm getting 1? Plus, what is the expected amount of money I will be winning or losing if I get 2? Plus, what is the expected amount of money I'm winning or losing? Plus, what is the expected amount of money that I'm winning or losing if I get 4? Right? So these are the 4 possibilities. Now, let's just start with this possibility. Now, what is the probability of 1? This is 1 by 4. नहीं ये थोड़ा कॉम्प्लेक्स हो जाएगा एक्चुअली. ओके, लेट्स जस्ट डू वन थिंग. Actually, I have divided my sample space in something like this, that in this particular case, so basically these branches are all the possibilities, right? All the branches are all the possibilities. If I just expand this 2 in the 3 branches, then how many possibilities are there? These are the 3 possibilities. These are the 3 possibilities, 6 7 8, like that. I mean, if I just say that if I am dividing my sample space, then these are all the possibilities, right? So, okay, with 1 by 4 into 1 by 3 probability, I will be losing 10. Is this okay to everyone? With 1 by 4 into 1 by 3 probability, I will be losing 10. Right? Similarly, with 1 by 4 into 1 by 3 probability, I will be winning 10. Right? Similarly, with 1 by 4 and 1 by 3 probability into 1 by 3 probability, with this probability, I will be again winning 10. Right? So you can easily check that these two are the same numbers. So finally you got 10 by 12 basically, right? 10 by 12. So from this branch, you are getting 10 by 12. Now, similarly, this 2 is no different from this one, right? 2 and 1, because of symmetricity, either you say 1 or 2, doesn't matter, I think. I hope that is okay to everyone. So that's why I can have one more 10 by 12. Now, these two branches are left only. Now, with 1 by 4 probability, so I will say, maybe I can just write in that way. See, currently I have these two numbers, which I got from 1 and 2, right? 1 and 2. Now, what about other numbers? Now, I will say with 1 by 4 probability, I will be winning 10 rupees. Similarly, into 2, you can do with 1 by 4 probability. This is 10 by 4, right? So, I think you got 10 by 12 plus 10 by 12, which is 20 by 12 plus 20 by 4. So, which is equal to, can anyone tell me? 80 by 12, right? Which is 20 by 3. Yeah. So 20 by 3 is your answer. Have you understood this, what we have done? So basically, we have just created all the possibilities. In what possibility you might be winning, in what possibility you might be losing, right? So these are the two balls. So I will say I have just expanded the tree to 2 levels, but not for 3 and 4. Because there is no benefit of saying 3 and 4. Because if I'm having 3 at the first ball, then definitely I will be winning. So I can expand my tree, and I have just calculated. I've just done one thing. I've just multiplied all the probabilities, which is in this case 1 by 4 into 1 by 3, and then this number, because with this probability I will be winning or losing this number. So I'm just multiplying all the branches, right? And how many such branches are there in this tree? 1 to 3 branches, and 3 branches, 6 branches, and here I don't need to expand. So that's why 7 and 8 branches. Right? And for every branch, I'm just calculating with what probability you are doing, or you are winning or losing. So 20 by 3 is the answer. Okay. So I don't have the answer currently, but yeah, I know, I remember the answer, which is 20 by 3. Cool. Is this okay to everyone? Now let's just solve few more questions based on the same method. But these questions are even more tricky. Okay. Which is what we are calling recursive way of finding the expectation. So currently what we have done, we have used that method, which was seeming to be easy. Actually, it is easy after some practice, but currently it might seem tough. See, initially that was the very child version of that particular formula, which means that you were directly having this E1 and E2 and you were solving, right? I just shown you something which is little better question, little good question. And then now let's just see something even more better. Okay. So let's just see these kind of questions. Okay. There may be some other method of solving that earlier question. So maybe like you may have solved using some other method. You can just post that method maybe in the group, and we can discuss there. If you want, I can discuss here also. So maybe I can just proceed, and at the end of the discussion, we can see other methods which are there, right? Okay. So let's just see this question, which I've taken from some university, maybe that is University of UCI. That is from that university maths department. I have taken this question. So what they're saying, that Clark likes to buy a certain kind of lottery ticket, each ticket independently of other ticket yields one of the following price. So for every ticket, I'm saying for every ticket that like you will be winning 10 rupees with how much probability? With 1 by 20 probabilities, right? You will be winning 10 rupees with 1 by 20 probability. You will be winning 1 rupee with 1 by 5 probability. You will be winning 2 rupees two. Okay, this is not rupees. So you will be winning 10 rupees. You will be winning 1 rupee. You will not be winning anything. 0 rupees with 1 by 2 probability. And now they are saying you will be winning 2 free lottery tickets with 1 by 4 probability. So with 1 by 4 probability, you are winning 2 lottery tickets itself, right? So 2 tickets. Now they are asking that what is the expected payoff of a ticket? Okay. So for every ticket, like or on average, how much you are winning? Can you solve this question? This is 1 by 20. So you are saying this is 1 by 20 into 10 plus 1 by 5 into 1 plus 1 by 2 into 0 plus 1 by 4 into 2 tickets, right? So what does this mean to say 2 tickets? See, every other branch is very much sorted. Only thing which is left to right is 1 by 4 into something. Now, what does this mean? To say that, okay, you have won 2 tickets. Just think about it. Let E be the expected number of price on average you will be winning. Okay, expected number of price that you will be winning from 1 ticket. Okay, expected number of expected number of price from 1 ticket. And with 10 with 1 by 20 probability you will be winning 10 rupees, 1 by 5 1 rupee, with 1 by 2 probability you are not winning anything, but with 1 by 4 probability you are winning 2 tickets, which means how much you are winning actually in terms of rupees. Can anyone tell me? 2 tickets is okay, but in terms of rupees, see what is happening here. Is, as I'm saying, is the expected rupees from 1 ticket, right? The expected rupees from 1 ticket. Now I'm asking that what I should be writing here, which means that if I say E, which is the expected number of rupees from 1 ticket, which is actually something like this, 1 by 4 into, what should I write here? And then plus 1 by 2 into 0. So the only term which is remaining is this in this E formula. Is this okay? Till now the things are fine, or there is some issue? So what I'm saying here is that you are winning some rupees with some probability, and that's why I have written this formula, right? And now see, the E is the expected rupees from 1 ticket. And since you are winning 2 tickets, which means you are actually winning how many rupees? So we are talking in terms of expectation only. You are winning 2 rupees, isn't it? See, E is the rupee that you are winning from 1 ticket. If you are winning 2 tickets itself, then you are winning 2 rupees, isn't it? So finally, if you just try solving it, it will be equal to 1 by 2 plus 1 by 5 plus E by 2, right? So from here, can anyone tell me what is the answer? Which is E by 2 equal to, this is a 5 plus 2, 7 by 10, right? So E is 1 by 4. So which means on average, you are winning from 1 ticket, you are winning 1 by 4, 1.4 rupees. Is this understood? We can solve it using other method also, but at least this method is understood or not. See, you won 2 tickets, which means you have won. Since I'm claiming, I'm letting it that is the rupees that you are winning from 1 ticket. If you have won 2 tickets, then you have actually won 2 rupees, right? So that's why I'm writing 2e. But maybe we can just try solving it using other method also. Okay, don't worry. This is just a starting of this method, and I have many questions using that method. Like even I have the recursive programs just to just to analyze using this method. Okay, so that is the question that I have taken from Stanford. This is the Stanford slide, and which is a recursive program. So we will be doing it, doing many questions, okay, using this method. So it will be very much habitual. And then obviously whatever we are teaching is not just for the sake of teaching. So we will be solving three or two, I think, two or three gate questions, 2-3 gate questions using this method, and one or two, I don't remember exact number, I think two or one TIFR questions. Okay, so there are 3 to 4 questions that they've already asked using this method. That's the only reason. I mean, we are studying this seeming complicated method, but actually it is not. Okay. Okay. Saurabh is saying that. Can you repeat that earlier method again? See what I'm saying here. That is the expected amount of rupees that you are winning just using one ticket. Okay, is the expected. Now, if you recall that, what is the total formula, law of total expectation? Basically, it says that E that is equal to, if this happens, then what is the probability of this? 1 by 20, then you will be winning 10 rupee. 1 by 5, with 1 by 5 probability, you will be winning 1 rupee. With 1 by 4 probability, okay, I need to write some other expectation here, right? I mean, you are winning some expected rupees plus with 1 by 2 probability, you will be winning 0. Is this okay to everyone? I mean, at least this formulation, right? Now, what they're saying that you have won two tickets. Now, can you tell me how much expected price you will be winning using those 2 tickets? How much expected price? See, this is the expected number, right? Which I need to write here. How much expected price you will be winning using those 2 tickets? So, using one ticket, since I assume that you are going to win E price, so expected price using 2 tickets is 2E. So here, this E1 itself is 2E, right? So that's how you can solve this question, and E is coming out to 1.4. Now, maybe what we can do here, maybe we can try solving it using some other method. I'm not sure how we can solve it, but let's just see. Okay. So what you got here, like with 1 by 20 probability you will be winning this, that is okay. The only problem is in this branch, right? How to interpret this branch, or how to solve this branch. Let's just see if we can do it. Now, what will I say? That here you have won 2 tickets, right? With 1 by 4 probability you have won 2 tickets. I don't know कि complicate हो जाएगा या फिर नहीं, but should I try this now or after some examples? That also I don't know. Maybe let me just try it now. So see, here you have won two tickets. Now, let's suppose these are the 2 tickets that you have won. Okay. This is the ticket 1. This is ticket 2. Right. Now, using this ticket 1, aren't you having the same conditions again? That with 1 by 20 probability, you will be winning 10 rupees. With 1 by 5 probability, you will be winning 10 rupees. So can you take this question? Yeah, if it is okay, someone has sent me some link. So if it is related to this particular concept, then we are going to solve it in 2 days or tomorrow lecture. Okay, is this the same question? Your username is P. Can you send me a screenshot of that question? Maybe. Okay. So with 1 by 4 probability, you will be again winning 2 tickets. With 1 by 2 probability, you will be winning 0, right? So with the ticket 1, you will be repeating the same story. With the ticket 2 also, you will be repeating the same story. Is this okay to everyone? With both the tickets, you will be just doing the same thing, and you will be having the same story, right? Now tell me how many branches you have in this case. See, this is 1, 2, maybe you can say 3, and then this is, I mean, how many leaps basically? So 1, 2, 3, 4, 5, 6, 7, maybe 4 here also. 7 plus 4, I can say 11, isn't it? So let's do one thing. Let's just sum up all of these 11 branches. Okay, there is one question. Yeah, these kind of questions we will do. We will do these kind of questions, right? Sorry. So what you will say, the expected amount E is basically again the same thing, which is money, expected money with the one ticket. So what should be the expected money? That E is coming out to be. Can you just tell me what should be E? It should be 1 by 20 into 10 plus 1 by 5 into 1 plus 1 by 2 into 0, and then plus 1 by 4 into all of this drama, right? And what is that drama? 1 by 4 into 1 by 20 into 10. So it will be 1 by 4 into everything, like 1 by 20 into 10 plus 1 by 4 into 1 by 5 into 10 plus 1 by 4 into 1 by 4 into again these two tickets. So now, like, see, it will be, I think, very complicated. So let me just assume that these two tickets is like, I mean, see what we did earlier. We assume that these two tickets, not assume, but we have put the value of the two tickets as 2E here, right? But in this case, what we did, we have not realized that it is 2E, and we have just expanded the tree unnecessarily, right? No, you can do it. I mean, it will be very complicated. I can do it, but I think these are the two tickets, so it will be infinite series. It will be infinite series. But if you want, what you can do here itself, you can realize that it is just 2E. It is just 2E, right? Here itself, you can realize that this two tickets is just 2E, and then again 1 by 2 into 0, and since it is repeating the same thing, so that's why 2 into the same thing, right? Abhay, you must have done some mistake. So let's just continue. Maybe after some example you will get to know, because we will do that method also with some other questions. Maybe you have watched the previous lectures, and that's why probably you're talking about the same method. Okay. Anyway, is this understood to everyone what we are doing here? See, earlier what we did. Earlier we realized that this two tickets is just 2E. Will give you 2E, right? And then we stopped my tree here. We stopped the tree here itself. Is this okay to everyone? But here we have not realized it, and I just try to expand it. Even if you expand it, then let's suppose at this moment you realize. I mean, it is just a point wherever you are realizing. So if at this moment you realize, then you will say that this two tickets is just 2E. And you can solve this particular equation also. I guarantee you that you will be getting E equal to 1.4 only. If you want, you can try solving it. So by the way, have you understood what we are doing here? What we did earlier is basically we stopped here because of this two ticket recursion, right? We stopped the recursion here, and we said like these two tickets is just 2E. But here we are not stopping. We are saying that let's just move one more, maybe one more level, because I have not realized that this two tickets means recursion. But let's suppose after one more level, I realize that, okay, this two tickets means recursion only. Then also it is fine. I mean, you can just sum up all the probabilities, and then instead of these two tickets, you can write 2E, and then you can solve it, right? And then you will be getting the same answer, which is 1.4. Okay. So 1.4 is the correct answer. Okay. Now, do you want to solve this question? Or, I mean, do you want me to solve this question, or do you want this question to be homework? Because now you should be able to solve this question. So what this question is saying, at least let me just tell you what this question is saying. A mouse is trapped in a room with three exits at the center of maze. So basically, it is having three exit 1, exit 2, and exit 3. This is a maze. Okay, exit 1 leads outside the maze after 3 minutes. Exit 1 is basically after 3 minutes, you will go outside. This mouse will go outside. Exit 2 leads back to the room itself after 5 minutes. Okay. Exit 2 is saying after 5 minutes, you go to the room itself. Exit 3 is saying after 7 minutes, you will go to the room itself. Every time the mouse makes a choice, it is equally likely to choose any of the exit. What is the expected time taken by mouse to leave? So let me just go to the next page and let me explain this question properly. So at least let me just explain this question. So what is happening? This mouse is here. There are three probabilities, right? Either it chooses exit 1, or it chooses exit 2, or exit 3 with equal probabilities. Okay. Now let's suppose E is the amount of time, expected time to exit. Expected time to exit from room. Okay. If we are standing here, if mouse is standing here, then with 1/3 probability, it will go to exit 1. And in how much time it is leaving the room? Can anyone tell me what is that number I should be writing here? It is 3, right? In 3 minutes, it is leaving the room. If you go here with 1/3 probability, if you go to the exit 2, then what you are doing? That's very important to understand. You are spending 5 minutes. That is okay. But you are again back to the room, isn't it? You're spending 5 minutes, but you're again back to the room. That is important. Which means your 5 minutes got wasted. So if you choose this exit 2, then how much amount of time in aspect, how much amount of time or the expected time you will be leaving this room? 5 minutes you have wasted, and then you are in that same room. So and as I assumed that E is the amount of time that you take to go out of from this room. So basically, if we are at this room, you take 5 minutes, you are at again at the same room, which means you have wasted your 5 minutes, and then you will anyway going to spend this E amount of time. This is just wasted, right? Wasted. And this is basically, you can say, in future you are anyway going to spend E amount of time, because that is my assumption, that if you are in some room, in this room, then you spend E amount of time to go out of this room, right? This is not the assumption, this is the definition of E. That's how we are solving. So this is you just did, and that's what you are going to do in future, because you have wasted your 5 minutes if you're choosing exit 2. If you're choosing exit 3, you have wasted your 7 minutes, you're again to the same room, right? Again to the same room. Manish is saying, why 5 plus E? Why not 5 into E? Okay, this is a question where I should be asking you that why 5 into E and why not 5 plus E? You are asking me that why 5 plus E and why not 5E, but I will ask you the reverse question. Why you are thinking that 5E, right? From where you are thinking 5E? It is just that the amount of time, like, if at 9 a.m., let's suppose if it is 11 a.m., this is 2 hours, right? And from 11 a.m. to, let's suppose, 12 p.m., this is 1 more hour. So this is 2 plus 1, 3 hours, right? Total. You don't multiply these 2 hours. You just say the 2 plus 1, this is 3. Okay. So basically, we are adding the time. 5 minutes you have wasted, and in future you are again going to waste, or you are again going to take E amount of time, right? Okay. So Twinkle is giving some explanation that why not 5E, but that explanation is also not good. That is not correct explanation. So whatever you are saying won't is not making much sense. So basically, it is not 5 into E, because it is 5 plus E, because it is time which we are adding. 5 minutes you have wasted, and in future you are going to take E amount of time, right? And here you are going to take 7 plus E time. Is this okay to everyone? The way we are making the tree diagram? Okay. So now what you can do, Now you can basically find out this E. How? This E will be 1 by 3 into 1 by 3 into this 3, 1 by 3 into 3 plus 1 by 3 into 5 plus E plus 1 by 3 into 7 plus E. Okay. So I think if you solve it, you are going to get E equal to some number which is 15. Okay. So have you understood this question? This was a nice question, right? This was just to let you know that, I mean, how to solve this kind of question. Has any one of you attempted AIMT 3? All India Mock Test 3? Any one of you? Okay. There was one question actually in AIMT 3, just like that. Not exactly like that, but yes, it was like that. There was one program that I gave you. Okay. So that question was something like that. There was some program, and I think I don't remember the exact question, but there was some while loop. Okay, there was some while loop. I was saying with some probability you go to this particular path or something, and then I was asking that what is the expected number of trials you take to go out of this while loop. This was the question, and here the same question we have asked. Here the same question we have asked in terms of maze, right? I mean, there was a question that I was just asking. In the while loop there was a condition. Okay, in the while loop there was condition: if something happens, then you break this loop. Okay, which means you go outside this loop, otherwise you continue in this loop, and this condition was true with some probability. So basically I was just asking that how much trials you will be making in this while loop, how much iteration you will be doing in this while loop, something like that. That question was really nice. That was in the AIMT3. Okay, so let me know your doubt here. Supriya is asking, sir, we are able to do this recursion with E because expectation is defined over infinite number of trials. Yeah, basically because of the formula. Basically, the formula says that everywhere you write the expectation, expected number of time. If with this probability, how much expected time you will be taking? With this probability, how much expected time you will be taking? See, the formula itself is saying, see, with this probability, how much expected expectation of what is the expected on this? With this probability, what is the expectation of this? Like that, right? Okay. So what are the other doubts? Prashant is saying, isn't it strange that 7 plus 5 plus E is equal to 15? Okay, 7 plus 5 plus 3 is 15. Let me just think about some logic about it. Seems interesting. I think we can find some logic. No, this might not be a coincidence. Reason being the probabilities are same. Actually, the probabilities are same. That's why I'm thinking that there must be some logic. If that the probabilities are not same, there is a coincidence. But the probabilities are same. That's why I'm thinking that why 7 plus 5 plus 3 is also 15. Okay. Can't think of any logic as of now that why 7 plus 5 plus 3 may be 15. From this E equation, yeah, that is coming out to be 7 plus 5 plus 3. Yeah, maybe you can just try it out with XYZ. Maybe it is XYZ in this case, X plus Y plus Z. Anyway, like let's just focus on the concept. I hope the concept is clear to everyone. Okay, cool. Now, are you ready to do this question? This question I have taken from Stanford, and that's really very nice question. Mhm. 1 second. Okay. Yeah. So what they are saying, consider the following recursive function int near, and then they are saying that there is a variable b that can take any value between 1 to 4, and every value is equally likely. Either it is 1 or 2 or 3 or 4, right? And okay, first of all, if you are not comfortable with this return, else if, and these kind of things, then don't worry about this question. You can completely skip this question as of now. Okay, skip this as of now. If you're not comfortable with this, the programming syntax, we will learn it in the C programming. Now, what they're saying that if y is a value that is returned by this function near, then what is the expected value of y? Which means that what is the expected value that this near is returning? So I think that's an easy question. If you want, you can try it out. So see, there are 4 cases, right? Either b is 1 or 2 or 3 or 4. If b is 1, then what do you return? You return 2. Here you return 4. If b is 3, then you return 6 plus whatever near is returning on average, which is e, right? That's what my assumption is, that e is the amount that near is returning. E is the number that near is returning, right? So this is 6 plus e. This is 8 plus e. And everything is equally probable. So I think this is 2 plus 4 plus 6 plus e plus 8 plus e divided by 4 equal to e. Now from here, you are getting e equal to 10. Okay. So I hope that is fine to everyone. So that's how you can solve this particular question, right? If we take n wage probabilities as same and take n minus 1 wage back to the start, then addition is the answer. Okay. I don't know. So you are saying n wage probabilities as same. Okay, maybe we can discuss that those logics on the Telegram group. I'm not currently getting what you are saying. If n wage probabilities are same and n minus wage back to the start, then addition will be same. Okay, you are saying the same thing. You are generalizing the same thing. I don't know. Maybe you can try it out. Yes, exactly, Twinkle. So Twinkle is saying that if we could have gotten this question maybe 1 hour or half an hour before, then this question could have been one of the most tough question. Maybe you will get scared if you directly see these kind of questions in the examination. So see, my point is not to obviously do any complicated or any unnecessary question which are irrelevant to gate. Like everything that we are teaching or everything that you are studying will definitely be related to gate. So we will be solving gate PYQ just using this method. Don't worry. It is just that we have just built some foundation. Okay. So obviously, like every of the concept that we have studied, those will be followed. Like after those concepts, we solve gate PYQs. Okay. So if I'm not solving gate PYQ, it doesn't mean that it is not relevant to gate. It is definitely relevant to gate. Then only we are studying that. Cool. So I hope you understood this. Now, do you would like to try 2 variations of this question? Do you like to try some variation of this question? Okay. So there is very interesting variation. You might not be able to currently do it, but okay, there is a variation that I also don't remember. That is in the Stanford slide only, and that variation is basically related to 2 functions. They have not given 1 function that time. They have given 2 functions. One was near, another was far. Near is same as it is. Far was actually calling near. Okay, and then they were asking the expected value returned by the far. That was a nice question. We might solve it. Actually, you will be able to solve it after some gate PYQs. So we will be first solving the gate PYQs. And here, like currently, we are just making one equation. If you notice, we are just making one equation of E in all the questions, right? In all the questions, we are making just one equation of E. We will be solving some gate and TIFR question where we will be making 2 equations of E. Okay, where we will be making 2 equations of E. And then you should be able to solve these kind of questions. I'm talking about where these are the two functions. Okay, we will be solving those two equations question first, and then you can then I will give you this variation as an homework. Okay, so I hope you have understood this particular method. Don't worry, we will be solving more questions in the recorded videos. So but today I just wanted to tell you this method little bit. Now let's do this question, which is saying that what is expected number of tries to get 6 when rolling a die. Okay, so let's assume that this dice is fair and 6 faced. Suppose that this is given in the question itself. Now they are saying that you roll a die and you want to get 6. How much tries on average, or maybe like expected number of tries means that like how much try do you expect? Okay, so I mean there are two ways to interpret it. Is one of the ways is that like on average, if you conduct this experiment multiple times, which means you roll a die enough number of times, or you roll a die few times and you get 6 at the end. Okay, this is one experiment. You roll again and then you get 6 at the end in just fewer dice, fewer tries. You roll again, then maybe in the first try you get 6, and you roll again, then you maybe in the after many tries you get 6, and then you get the average of all the tries. Let's suppose this is the 5 tries, this is 3 tries, this is just 1 try, this is 10 tries, something like that. And then you take all of the average. Then how much like what will that number? So this is what they are asking. Or maybe in other words, you can understand like you don't repeat it multiple times, you just do it once, but how many tries do you expect, right? You just do it once, and how many tries do you expect? That's what they're asking. So like okay, let's just solve this question. Probably you will get to understand what do I mean by that. Now what will happen, that when you are rolling a die, suppose you are here, when you are rolling a die, maybe 6 can come and maybe 6 can not come. There can be only two cases with respect to this particular problem. Now if 6 is coming, then see in this case, let's suppose like always define a random variable. Let's suppose first of all x is a random variable, which is number of tries to get 6. Okay, whenever they ask expected number of something, just remove this expected, and whatever is remaining expected number of tries to get 6 or whatever, right? This is your random variable x. So this is number of tries to get 6, and then they're asking expectation of s, expected number of tries to get 6. Okay, cool. Now only two things can happen. Either 6 can come out or 6 doesn't come. If 6 comes, then how many expected tries or how many tries you are making? Just 1 try, right? See, let me just go to the next page and let me just try to explain this. What I'm trying to say here is that either 6 will come or 6 will not come. If 6 comes, then you are definitely making 1 try, right? And then that's over. So this is, let's suppose e, or e of x is expected number of tries to get 6, or let me just write e, expected number of tries to get 6, right? Now if 6 comes, then only 1 try. If 6 doesn't come, then 1 try you have already made. 1 try you have already made. Then how many extra tries you will be needing in future? This is the extra in future that you need, right? And 1 is already done, so this is already done, right? Now how many tries you will be needing in future? That's my question. So before that, let me just write the probabilities here. So if 6 comes, then the probability of 6 is basically 1 by 6. If 6 doesn't come, then there are five possibilities where 6 doesn't come, so this probability is 5 by 6. Now expected number of tries is basically 1 by 6 into 1, because this is the expected number of tries if you get 6, plus 5 by 6 into 1 plus something, right? 1 plus something, or maybe let me just write 5 by 6 into something, basically, right? So we need to fill this with something. That is my particular ask, to fill this. So what you will do, see, if 6 doesn't come, then how many tries you need? That is my question, right? So here you will say the number of tries that you need is 1 plus something. And what is that something? If 6 doesn't come, then don't you have to restart in this case? Which means it doesn't matter if you have already performed performed one try, it doesn't matter. You have to restart. So how many tries? One try you have already wasted, right? This is the wasted try. And in future, how many tries you will be needing? If you're restarting with nothing, you will be needing E tries. And because that is my definition of E. I mean, that's how I define this E for this particular question. That E is the number of tries you need to get 6. Expected number of tries to you need to get 6, right? So here, if you are restarting, then how many tries you need to get 6? E. So that's how you can make this recursive formulation, right? This is the recursive formulation in E, and that's how you can make it. So maybe I can go to the next page and I can try solving it. E equal to 1 upon 6 into 1 plus 5 upon 6 into 1 plus E. So from here, I can say that this is 1 upon 6 plus 5 upon 6 plus 5 upon 6 E, which is equal to E. This is 1. This is 1 by 6 E equal to 1. From here, E is equal to 6, which means expected number of tries, which means if you want to get 6, then you can expect that in 6 tries you can get 6, right? And that's the basically the perfect definition of the probability, which means that if the probability of getting 6 is 1 by 6, then in 6 tries you must be getting 1 time, right? On average. Yes, I agree, on average. But if I just want to draw the perfect sample, if I just want to say that okay, only on one sample this happens, which means that only on one try it happens, then you will say that okay, in 6 tries you will get 1 6, because the probability of 6 is 1, right? So 1 by 6. So basically that's what it is happening here, that expected number of tries to get 6 is basically 6, which means in 6 tries you should be getting 1. And that is not the exact thing, which means it is not necessary obviously in 6 tries you will be getting 1. That's why it is expected, right? It is not actual. It is the expectation. It is your expectation. So this is the one way to understand it. Or otherwise you can understand like that if you do it multiple times, if you get 6 one time, then just drop that experiment, right? Just like this. See, okay, I think, see here, you do it once, you get 6, you do it again, you get 6. So, or you take or average of all those experiments, then you say that okay, this is the number of tries on average that you will be getting, which means 6 is the number of tries on average you should be making to get 6. Okay, now let's just do one thing. Let's just try doing this using some other method. So let's suppose this is the method 1 I'm saying. Okay, but we can try using some other method, which is, let's suppose, method 2. So what is happening here? You are saying that you are rolling a die, and in that case you are saying that 6 can come or 6 cannot come, not 6. Now suppose if I just say that okay, you have to restart, then why not just toss it again? Why not just roll it again? And then you will say that okay, again 6 may come and not 6. Then again I will say that why not roll it again? So again you will say 6 may come and 6 may not come, right? So let me just write it here. So what do I mean by that? That you are keep on rolling. You are keep on rolling, and then you are having two possibilities: either 6 will come or 6 will not come. If 6 come, then you will definitely stop. If 6 doesn't come, then what you will do? You will roll it again. That's all, right? Okay. So sorry. Yeah. So either 6 will come or 6 will not come. So maybe let me just roll it again. Either 6 will come or 6 will not come. And if not coming, if 6 is coming, you will stop. You will stop here, right? These are the stopping points. You will stop. You will stop. You will stop. But if 6 doesn't come, you have to do it again. 6 or not 6. If 6 comes, you stop. If not 6, you don't stop. You keep on rolling. Right? Okay. Now let's just calculate the expectation here. See, with 1 by 6 probability 6 comes. With 5 by 6 probability 6 doesn't come. Here also 1 by 6, 5 by 6. Here also 1 by 6, 5 by 6. Here also 1 by 6, 5 by 6, and so on, right? So you will say that number of tries you are making. So this is, let's suppose, x, which is x is defined to be the number of tries, right? So this is x, and x is 1, which means you are just making one try, which means you are just going here. This is just one try, right? So how many what is the probability to get just one try? 1 by 6, right? With 1 by 6 probability, you are just making one try. which means after that you will stop. With 5 by 6 into 1 by 6 probability, you are making 2 tries. You are making 2 tries with 5 by 6 into 1 by 6 probability. Maybe I can just show you with the next page. See, what is happening here is that you are having these probabilities, right, with these values of x with different probabilities. Now I am saying that you get 2 with 5 by 6 into 1 by 6 probability, which means you need 2 tries with 5 by 6 into 1 by 6 probability. Similarly, with 5 by 6 into 5 by 6 into 1 by 6 probability, with this probability you need 3 tries, 5 by 6 into 5 by 6 into 1 by 6 probability, right? Similarly, 5 by 6 into 5 by 6 into 5 by 6 into 1 by 6, with this, see, this is 1 try, 2 try, 3 try and 4 try, right? This is 5 tries. With this is basically 5 by 6 power 1, 5 by 6 power 2, 5 by 6 power 3 into 1 by 6. With this probability you need 4 tries, and so on, right? And so on. Now you need to find the expectation. If we have the PMF of x, this is the PMF of x, isn't it? If you have the PMF, you can find the expectation using PMF, like the infinite series, and PMF is basically having the infinitely many values. Although these values are countable, countably infinite, like you don't need to know the what is countable and all, but yeah, like these are the natural numbers, so that's why these has to be countable. You will get to study in either discrete mathematics. I think in the TOC you will get to study this. Okay, cool. Let's not worry about it, but we need to find the expectation, which means we can multiply these numbers, right? We can multiply these numbers and we can find out the expectation. So, which means this is 1 into 1 by 6 plus 2 into 5 by 6 into 1 by 6 plus 3 into 5 by 6 square into 1 by 6 plus 4 into 5 by 6 cube into 1 by 6. So, that's how you can solve this particular question. 4 into 5 by 6 cube into 1 by 6, right? Okay. Now just observe here that this particular series is very tricky, right? I mean, this is not very straightforward series. So let's just go to the next page and try solving this series. Sorry, I haven't copied it. Sometimes actually, I don't know about the software. There is some issue with the software. That sometimes the things doesn't get copy. I mean, even though I press the Control C, still it doesn't get copy. But anyway, let's just cut it, and then I make sure that it get copied. If I cut it, okay, then it disappear, and then I make sure that okay, now it got copied. Cool. So now let's just try solving this series, right? This series is seemingly little complicated. This is an infinite series. Let me say that here this 1 by 6 is, I think, very much common. So maybe let me say 1 by 6 is common, and now this is 1 plus 2 into 5 by 6 plus 3 into 5 by 6 square plus 4 into 5 by 6 cube, like that. Can you just recall that what kind of series it is? If you have done the fundamental course, then there is something called AGP series. Why? Because here you have GP, here you have GP, and this is in the AP, right? So you can solve this AGP series. How? Let me just show you. See. Maybe for the sake of just this question, let me just assume that to be x. Okay, x is 5 by 6 because in that way it will be easy to write. So I can just write it in this way: 1 plus 2x plus 3x square plus 4x cube, and then so on, right? I will just substitute x in just a minute. I need to actually solve this particular series. Right? Okay, so let's just go to the next page, and then let's just try solving this series. Let's assume that this is s. Then what is xs? If you remember, then we actually multiply with the common ratio, which is x here. It will be x plus, see, x plus 2x square plus 3x cube plus, and so on, right? And then you can do one thing, you can subtract from each other. This will be I think s minus xs equal to 1 minus 1 plus x square plus x cube, and so on. And since this is a normal GP, which is 1 upon 1 minus r, and here you have s into 1 minus x, right? So from here s is coming out to be 1 upon 1 minus x square. So s is 1 upon 1 minus x square, which means this particular quantity into 1 by 6 is e. This is s, right? This is s. So e will be, let me go to the next page. E will be 1 upon 6 into s, which is 1 upon 6 into 1 upon 1 minus x square. And since x is 5 by 6, so that is why this is 1 upon 1 by 6, right? 1 upon 1 by 6 square, and from here you can see that it is easily, you can see that it is 6, right? So you can solve using that method also, which means that if it is not getting clicked in your mind that okay, from here itself you can write this e, that's not an issue. You can just grow this tree to infinite level and then you can solve this question. I hope that is okay to everyone. How we are solving? Because we are keep on rolling. We found out the PMF and then we solve this question, right? But obviously, which method is recommended? This method one is recommended. Definitely it is recommended. Why? Because it is just one-liner solution. If you do this, then you have to solve GP, you have to solve AGP, you have to do many of the things, right? So that's why I don't recommend it. Okay. Now, let's see one more method, which is essentially just either method 1 or method 2, but still like just to give you more clarity, let me just tell you one more method. So see what is happening here. You are rolling a die and 6 can come or not 6 can come, right? I mean either 6 will come or 6 will not come. Then in method 1 I said that you stop here right away, and here you just say that this is 1 plus e, here you will say this is e. In method 2 I said you can just expand it further, right? So let's just see a middle ground, which means let's suppose you expand it further, you say that this is 6, this is not 6. And then at this moment, you realize that you are repeating the same thing, right? So you will say, here the expected number of try is 1, here the expected number of try is 2, and here the expected number of try is, this is interesting, 2 plus something in future that you are going to do, which is e. Okay, in future. I mean, till now you have made 2, wasted 2, or till now you have made 2 or whatever you want to write. Okay, and in future you are going to make 2 e more. So if you write the probabilities here, this is 1 by 6, this is 5 by 6, this is 1 by 6, this is 5 by 6, and then you can make the equation for e. Okay, so you can make equation for e. Let me just, okay, just a second. Let me just make equation for e. So what will that equation? You will say e equal to 1 by 6 into 1, that is okay. 5 by 6 into 1 by 6 into 2, 5 by 6 into 1 by 6 into 2, that is also okay. Plus. Now just see here what you are going to write. Plus 5 by 6 into 5 by 6 square. I mean 5 by 6 into 5 by 6 into 2 plus e. 5 by 6 into 5 by 6 into 2 plus e. Right? Why? Because you are doing the same thing again and again. So why not write e here? Now let's just see if I am getting the same thing from here. E equal to 1 by 6 plus 5 by 6 square into 2 plus 5 by 6 square into 2 plus e. Right? So this is 36 I think, and then this is 6 plus 10 plus 5e equal to 36e. So let's just solve it. This is 26, and then you can say that I think this is 5. Okay, let me just check if there is some mistake. Yeah, 6 plus 10 plus 5e. Yeah, sorry, this is 5 square. Okay, sorry, this is 25 into 2. This is 50 plus 25e. Okay. Now this is 60 and 66, right? This is 66, and here you will be getting 11. So here you can say this is 11e, right? 11e equal to 66, which means e is 6 again, right? So how we are solving this question? I mean, we are just saying that let's suppose we have not realized that you can stop at this point, but later I realize it. So why to go infinity? I mean, even you can realize it after a bit more, which means even if you solve it like this, let me just show you what I mean to say. Okay, if you want, you can call it method 4, but essentially it is not, obviously a different method. But okay, so see, even if you do not realize, see, it is good that you have realized it here, right? But let's suppose you even do not realize it here also, right? Suppose you realize it little later, which means you say that, okay, let me expand it further. And now here also you say 6 comes and not 6 comes. And here you realize, so this is 3, this will be 3 plus e. Now can you write the equation? This is 1 upon 6, this is 5 upon 6. Yes, 1 upon 6 into 1, 5 upon 6 into 1 upon 6 into 2, 5 upon 6 into 5 upon 6 into 1 upon 6 into 3, 5 upon 6 into 5 upon 6 into 5 upon 6 into 3 plus e. And you can solve that equation, you will be getting e equal to 6 also only. So basically, I mean, it is the point that where you are realizing. In method 2, I told you that suppose you are even going to infinity, that is also fine. Okay, this is also fine, you are going to infinity. But if you want, you can just stop it right away. So this is the most recommended method. This is the most recommended method. Just stop it right away, right? And if you want, you can stop it in the between also. If you want, you can stop this process in the between. So the final answer will not change, right? I hope you understood all the methods and you have understood the interpretation of this. Now, interestingly, this is a common phenomena. I will just tell you that what do I mean by that common phenomena. Actually, this particular question is not just limited to probability. You will see this particular question more often in almost all the subject. Okay, so I will tell you after one more question probably. Okay, let's just do one thing. Let's just do this question. Maybe you can do this question as on homework. Okay, and we will be just solving this question in the next video. Cool. So just try this question and let me know what is the answer you are getting. Let us now see this question, which is saying that a coin is tossed, the probability of getting head is P. Okay, you're tossing a coin, the probability that you get head is P, which means the probability of head is small p, and which is a non-zero number, and which is also less than 1. Let n be the random variable denoting the number of tosses till the first head appears, right? So they have defined n to be a random variable, the number of tosses till the first head appears. Including the toss where the head appears, which means let's suppose the third head appears at let's suppose, oh sorry, the head appears at let's suppose at this particular toss, which means third toss. Then n will be 3, which means including the number where the third toss, like including the toss where the head has actually appeared, right? Okay. So they are saying, I mean, see, in this case n will be 4, and in this case n will be 5. I mean, here the n is 4 because you need to count till head. It's not 3. It's not like before head you need to count. No, it's 4, right? Okay. Now they are saying, assuming that successive tosses are independent than expected value of n, which means how much number of tries on an average, or how much number of tries do you expect such that the head appears, right? See, what we can say here is that there will be two things which will occur. Either head appears or tail appears. If head appears, then you will stop right away, and then you will say that n value is 1. If tail appears, then you can say that you have already spent one toss, and now in future you can spend e number of tosses, e or n, whatever you want, you would like to say. No, okay, let's suppose this is e. I mean e of n or just e, whatever you would like to say, right? So from here you can just make an equation which is 1 by 2 into 1 plus 1 by 2 into 1 plus e. Now which is 1 by 2 plus 1 by 2 plus 1 by 2 e, which is implying e by 2 equal to 1, which is basically e equal to 2, which means expected number of tries to get, okay, sorry, this is not 1 by 2, right? This is p. So let me write p here. P and 1 minus p, I think. Okay, so let me write p and 1 minus p. So this is e equal to p into 1 plus, so this is p and this is 1 minus p. This is 1 minus p, this is p, p into 1 plus 1 minus p into 1 plus e. So this will be p plus 1 minus p plus e minus ep, and that is e equal to, which is getting cancelled out, and then this is 1 plus e minus ep, I think, right, equal to e. This will get cancelled out, this is 0, so ep is 1, and from here e equal to 1 upon p, right? So that's how you can solve this question, which means expected number of tries to get head is basically 1 upon p. So what is the correct answer here? I think A is the correct answer. So as I told you that this particular question is not just limited to just probability. Like in many different cases you will see this particular question. So the question may be something like this. See here I'm saying the head, right? They will say the success. So here getting head, I mean you can define your success in any way. Like getting head is a success, or maybe getting tail is a success, whatever is success for you. So they will say that probability of success is, let's suppose they will say P, the probability of success is P. So how many trials you need to make such that the success happens, right? How many trials such that you get succeeded? That is equal to 1 upon P, right? For the success you need 1 upon P. How many expected trials basically? So this is one template, I can say, right? This is a template of question that they might be asking. Instead of success, they can say head. Instead of success, they can say some other thing also, right? But this is the template. Okay. Now, maybe I can go to next question. Or maybe let me just give you one analogy or one particular question that is in the computer networks. Then they can say that suppose this is a sender which is sending something to a receiver, and this sender is basically sending a data or data packet with a probability, I mean get to the receiver with the probability p, let's suppose, right? And with 1 minus p probability it doesn't get to the receiver. Then how many packets you need to send such that you make sure that packet has been delivered? Okay, so the probability of receiving packet, you can say receiving packet successfully, is P. So expected number of packets, expected number of tries, every try is just one packet, right? Expected number of tries or expected number of packets, whatever you want like to say, expected number of tries to send just one packet successfully. This is basically equal to how much? 1 upon P, right? I mean, this kind of question people ask in computer networks. So as I said, like this particular type of questions are not just limited to probability. So they will be asking this kind of question in computer networks. So we will see this later, right? Let me write it here. We will see this later. In fact, there has been gate PYQs. Exactly this. This is actually a gate PYQ. Gate PYQ in CN. Exactly this, nothing changed. Exactly this, there has been one gate PYQ. Actually, this is a template. I mean, they will say the probability of success is P, then how many tries you need to get succeed, which is 1 upon P, right? And like you can see that has been asked in probability. Exactly same PYQ, just saying that, okay, sender receiver, that has been asked in computer networks. Exactly same PYQ, same particular question has been asked in many places, right? So I hope you understood this template. Now, let's just solve this question which has been asked in TIFR. This is very nice question. What they're saying, Ram has a fair coin. So, first of all, like, sorry to go back in this question. We have just solved this question using method 1. Right? I just ask you to solve this question using method 2, just for your sake of practice, and method 3 as an homework. Okay? These methods are homework for question 9, just for your sake of practice. Just do these questions as an homework. Now let's just do this question. They are saying Ram has a fair coin, that is toss of a coin result in either head or tail. Each event happens with probability 1 by 2. Okay. He repeatedly, so they are saying that probability of head and probability of tail is 1 by 2. He repeatedly tosses the coin until he gets heads in 2 consecutive tosses. So this is very interesting. Now they are not saying that until he get head. They are saying you want to get 2 heads in a row, right? In 2 consecutive rows. The expected number of coin tosses that Ram does. So how many tosses he needs to get 2 heads in a row. So basically this is a question where we are asking 2 heads in a row, right? So what will happen? You may be getting head, you may be getting tail. If you are getting head, you toss it again. You may be getting head, you may be getting tail. You stop it here. If you are getting tail, then what you will do? So in these cases, what you will do? So this is the tree diagram. Here you have spent 2 tosses. Here what you will do? What do you think? Want to restart your process, right? You have to restart the process. Here also you have to restart the process. So you will be restarting your process. Now you can see that here you have already wasted 2 and then E in the future. You have already wasted 2 and E in the future. So this is 1 by 2 probability, this is 1 by 2 probability, this is 1 by 2 probability, this is 1 by 2 probability. You will be writing E equal to 2 into 1 by 4. With 1 by 4 probability you need 2 tries. With 1 by 4 probability you need 2 plus E tries. With 1 by 2 probability you will be needing 2 plus E tries, right? So let me go to the next page. The E is, with 1 by 4 probability you will be needing 2 tries. With 1 by 4 probability you will be needing 2 plus E tries. 2 plus E tries or tosses, plus 1 by 2 probability you will be needing sorry, this is not 2 plus E, this is just 1 plus E. That's interesting. This is just 1 plus E. With 1 by 2 probability you will be needing 1 plus E, right? Now let's just solve it. This is 1 by 2 plus 1 by 2 plus E by 4 plus 1 by 2 plus E by 2, right? So this is 1, this is 1 plus this is 1 by 2 plus this is 2E by 4 and then 3 by 4. This is E, right? Okay. So that is why you can just solve it. This is I think 3 by 2. This is 3 by 2 and then E by 4 equal to 3 by 2, which is I think E equal to 6, right? So you need 6 tries on average to get 2 heads in a row, right? So I hope you understood this question. Now this is just using the method 1 I did. If you want you can do using method 2. This is just using method 1. Maybe let's just try using method 2. Method 2, actually it is an infinite series for the method 2, but instead of infinite series, like actually the infinite series is little tricky here. That's why I just want to try the method 3, I think, where I will just grow the tree partially. Okay, so this is partially growing the tree, partially growing tree. I mean, I don't need to do it because these methods are just for your sake of illustration. Always we will be using method 1, but still, let's just see. This is head tail, and this is head tail. And instead of stopping here, I say that I can restart. I'm again doing head tail. Let's suppose I grow this tree to this level. Okay, like let's suppose this is the tree that I have. So here 2 tries, here 2 plus E, here. Okay, that's interesting. If you get head, you can't restart, you can't stop, right? So maybe with the head, I think let's just do it in this way. Yeah, so you will stop here. This is 3, this is 3 plus E, and then this is 2 plus E, right? So the probabilities are here. This is 1 by 2, this is 1 by 2, everything is 1 by 2, 1 by 2, right? So you can write, I think, the equation. So 1 by 4 into 2 plus 2 plus E, the 1 by 4 into 2 plus E plus 2 plus E, 2 plus E, plus 1 by 8 into 3 plus 1 by 8 into 3 plus 1 by 8 into 3 plus E, right? So this is your equation of E, which is 4, 6 plus 2E, 6 plus 2E divided by 4, 6 plus E divided by 8. And this is your E, right? So you are getting how much? This is 8E equal to 12. 12 plus 4E plus 6 plus E, which is 5E, and then this is 3E equal to 18, which means E equal to 6, right? E equal to 6. So from here also you will be getting equal to 6. I hope you understood this. Easy one, right? Once you understand the complete method, then using either method 1 or method 2 or method 3, it is easy. Method 2 is basically infinite series, and I actually solved it, but infinite series in this case is very, very, very tricky. Last year we did that, but I don't want to do it now. Okay, so infinite series, because it's not worthy. Good. Now let's see this question. Let the random variable x represents the number of fair coin needed to be tossed until 2 consecutive heads. Oh, that's the same question, exactly same question that they've asked, isn't it? 2 consecutive heads. So here in TIFR they've asked in 2015. Oh, here also they've asked in 2015. Okay, that's awesome. That's in the same year they are repeating, right? Anyway, one was in TIFR, another one was in GATE. So and in the same year, the same question has been asked. That's probably by coincidence. Anyway, the expectation of x, the ex here will be 6. We have already solved it, right? The same question. This is same question. Okay. Now let's solve this question. What they are saying: an unbiased bias cone is repeated until the outcome of 2 successive tosses is same. And then they are asking the expected number of tiles. So they are saying that either 2 heads, or 2 tails, right? Either you want 2 heads or you want 2 tails, which means head or tail. That's what we want. This is what question is saying. Now let's just see either head comes or tail comes, and then here if head comes you will stop because you want either this, and then with the tail, because since it is not same, you will be doing it again. With the tail you will say that okay, head comes, tail comes. So here in these 2 cases you will stop. But here can you restart? Can you say 2 plus E, something like this, 2 plus E, something like this? So the problem here is that you can't restart because you have already gotten one tail. Now you are looking for one more tail, right? I mean, you can't say you're restarting. You have something to start with. Basically, you are not nullifying everything. You have one tail with you. Similarly, you have one head with you. So you actually don't need 2 plus E. 2 plus E is too much here, right? It is too much. Why it is too much? Because E is the number where you don't have anything, and then number of tries to get either head or tail. But here you have something. Right? Now, if you can't write 2E and neither you can stop, so should you go the infinite series or what you will do? So I mean, I'm not solving this question in this video. I will be solving in the next video, and I just want you to solve this question. I'm almost sure you want to be able to do it because this is the first question of a different kind, basically. Okay, so just try it, give it a try, and let's just see if you can come up with something. Okay, cool. So just give it a try. Yeah, we will be solving this in the next video. So this is a very good question, very, very tough, I can say. Okay, quite tough question, very nice question. Just give your best. Maybe even if it is taking 1 hour just to try this question, but it is worth. Okay, try out this question. Maybe even if it is taking 1 hour. We will be meeting in the next video. Yeah, thank you so much. Let's just do this question, which is basically they are saying that an unbiased coin is tossed. This is unbiased coin, which means it is a fair coin, repeatedly until the outcome of 2 successive tosses is same. Which means they are saying either head appears or tail appears. It is not like that only head they are focusing or only tail they are focusing. Okay, they are saying if either head appears or tail appears, they are fine. So for that, how many expected number of tosses are needed? Let's just see this. See, you will start with nothing. Either head will come or tail will come. Then obviously you will do one more time. Either head will come or tail. Right? Now earlier we restarted here because we wanted head. Now tell me, can I restart here? Just think about it. Can I restart here? Obviously no, right? Obviously no, because you have already made one progress of tail, because you are looking for tail also. So that's why you cannot restart here. That's the problem here, right? Okay. So earlier, I mean, this was the earlier, let me just write it. This was the earlier where I said that I can restart here. Earlier means you're looking for head. Okay. I said I can restart here. Maybe I can stop here. I can restart here. So earlier was quite easy, but now this question is actually tricky. I mean, tricky in the sense that I cannot actually restart at the desired point, or I cannot stop at the desired point. Okay. So that's why this question is little tricky. Let's just try solving it. So what we have, we start with nothing. We will either be getting head, or we will be getting tail. Okay. So I cannot restart here, and I have to explore this. I have to explore this also. That's interesting. I mean, we can do it, but I mean, we can actually explore to multiple trees, multiple branches. That's okay, multiple levels. But let me just say that till now I made one toss, and let me just say that in future, see, E. Let's suppose E is the answer for this question. E is the answer. Okay. Let's just say that in future I will be needing even tosses here. Okay, and here I have already made one toss. Let's suppose in future I will be needing E2 tosses. Suppose if I just draw the tree like this, and if I try to convince you that we will be needing, let's whatever we will be needing, I'm just calling it E1 and E2. And since this is a fair coin, so that's why it is 1 by 2, 1 by 2. So the final answer will be E, which is 1 by 2 into 1 plus E1 plus 1 by 2 into 1 plus E2. Even E2 some numbers, okay, that we are yet to calculate. I mean, one I already made, and then in future, let's suppose E1 I will be needing. And one I already made, in future, let's suppose E2 I will be needing. These are some numbers that I yet to calculate. So let me write the description for E1 and E2. E1 is tosses. Can anyone tell me, okay, can anyone tell me the description for E1 and E2? Tosses we need for head or tail, because we are looking for either head or tail. If we already have head in my hand, we already let me write. I already have head in my hand. Okay. And what about E2? Ekta and Akash is asking that why E1 and E2 are not same. When I said they are not same, I do not know, right? I mean, they could be same. We will be just calculating it. Let's just see if they are same or not. Okay. We will be calculating and we will check whether they are same. If they are same, then we will be getting E1 and E2 are the same answer. If they are not same, then we will not getting same answer. Let's just check if they are same or not. Okay. Sorry. 1 second. Yeah. So let me write E2 description also. Can you tell me what is the description of E2? So E2 will be, let me write it here. E2 will be tosses we need for head or tail, because that's my final goal. If I already have tail in my hand, this is the description for E2. Okay. Yes. Now let's just calculate this E1 and E2. So let me go to the next page probably, and let me calculate this E1 and E2. I hope the question is clear to everyone and the process is getting clear that we want to calculate this E1 and E2. I just assume that, okay, let's suppose this is E1 and this is E2. which means let me just calculate E1. So I will say I already have head in my hand, and now I'm looking for head, head, or tail, tail. Now either head can come or tail can come. Now tell me, what is the number of expected trials that I made, or number of processes that I made till this point? Just one, right? Just one. These are not two. I'm not counting from starting. I already have that starting point is different. I already have a one head in my hand. Okay, this is just one. Everyone agree with this? Now, what are the number of tosses that I need for head, head, or tail, tail in this case? See, I got tail in my hand, and now I'm looking for something else. So this is one plus something, right? One plus something. Now, can you tell me what is that something? This cannot be even. Reason being is that this cannot be again recursive. That's the problem. Reason being is that you are looking for head, head, and tail, tail, but you have already have tail in your hand, not head in your hand. You have tail in your hand, and you are looking for head or tail, tail. Then what it should be? Yes, Devananjan is right that it should be 1 plus E2. See, reason being is that one is one. I hope one is clear to everyone that why we are having one, because let's not worry about this particular problem. Okay, this particular problem is, let's suppose this is different. Let's not worry about this particular problem. Let's just focus on this problem that I want to calculate even, where the starting point is that you already have a head in your hand, and then if you're looking for head at just one toss, if you're looking for head or tail or whatever, okay, then you got tail, and then let's suppose you're looking for head at tail, but you got head tail till this point. So you made some partial progress, and then you will say that you already have tail in your hand, and then you are looking for head at tail. Basically, it will be 1 plus E2. I hope everyone is getting, but let me just complete the explanation, and then if there is any doubt, please tell me. Now let me calculate the E2. E2 means you have tail in your hand. Now either head can come or tail can come. Now you were looking for head, head, or tail, and since head can come, that's why you will not say that you can stop here, but you can stop here. I mean, there is just one toss that you need till this point, right? So there is just one toss that you need in this case. But in this case, how many tosses you will be needing? You will be needing 1 plus something. One is already done, but you have head in your hand, and now you're looking for something, which is header or tail. So if you have head in your hand, and if you're looking for header and tail, header or tail, then you will be needing even number of tosses. Okay, so I got this E1 and E2 diagram separately. I got E diagram separately. So there are 3 diagrams, but let me just sum this up. So for E1, you will be getting this equation. Can you write the equation for E1? E1 will be 1 by 2 into 1 plus 1 by 2 into 1 plus E2. ठीक है, ये समझ में आ रहा है? See, this E1 will be 1 by 2 into this 1, because the probability is 1, probability is 1 by 2, and then 1 by 2 into 1 plus E2. Then can you write the equation for E2? This is almost same, 1 by 2 into 1 plus 1 by 2 into 1 plus E1. Now from these two equations, can you calculate E1 and E2? These are the two equations, two variables. I think this should be easy. So let me just go to the next page. This is E1 is equal to 1 by 2 into 1 plus 1 by 2 into 1 plus E1. This is E1 equation I got. This is E2 equation I got, which is 1 by 2 into 1 plus 1 by 2 into 1 plus, sorry, this is E2. Okay. So let's just calculate it. What you are getting? Can anyone tell me the answer? This equation is E1 equal to 1 by 2 plus 1 by 2 is 1 plus E2 by 2. This is E2 equal to 1 plus E1 by 2. And then you are getting 2. Okay. E1 and E2 as 2. So from these two equations, you are getting E1 equal to 2 and E2 is also 2. Yeah. So initially we guessed that because of symmetricity, both should be same, but ultimately we also put both should be same. Okay. I mean, if we are convinced here only that yes, both will be same E1 and E2, because this is symmetric, because this is head, this is tail, and either we are looking for head or tail. So head and tail are replaceable to each other, which means this is kind of symmetric case. So initially, if you're convinced, then you can just make E1 and E1 at both the places. This will just save your time. Okay, if you're convinced. Otherwise, if you're a little bit doubt, just make even into it, and ultimately we got two equations, and then finally we are able to solve for even e2. If let's suppose if I just write even in both the places, then from this just one of the equation I could have got it. Suppose if I write even in both the places, let's suppose here also I write even, which means here also I write even, then it will be even equal to 1 plus even by 2. And then if you solve it, then even will be just 2. Right? There is just one even in d2. Okay, so I hope everyone is getting it. Now I got even in e2, which is 2 and 2. So now can you just write this tree? This is this. Okay, can you just write this even in place of the even? Can you just write 2? Can you just write 2 here? And then can you tell me what is the final answer you're getting? You are getting 1 by 2 into 3 plus 1 by 2 into 3. This is e, you know, which is 3. So e equal to 3 that you are getting. Okay, so final answer is 3. I mean, we will be solving with some other way also. We will be just checking that if we expand this tree further, then what's going to happen. But for now, let's just convince ourselves the final answer is 3. Reason being is that if you are tossing, that either head can come or tail can come. Then I'm probably suspecting that okay, I cannot stop here, I cannot restart here. So let's just make it even in e2. Okay, and then let's just calculate even in e2 separately, and then I will plug this later. So if I plug this later, then I'm getting this as an answer. So if I need to just get head, then I was getting 6. If you remember as an answer in the earlier question, I was getting 6. And for head or tail, I'm getting 3. I think this is also a bit justifiable that for head, if I'm getting 6, now if I just add some equivalent to it, which is head or tail, then I need, since I have more favorable cases basically, then I will be getting just half of this, which is 6 by 2, which is 3. Right? I mean, this is kind of, if you want to make some intuition, you can make. Otherwise, there is no problem. So let's just solve it with some other method. Okay, let me call it method 2. First, let me know if there is any doubt in the method 1. If everyone is clear, or there is some, see, there might be some doubts, because reason being is that you are seeing this at the first time. So that's why there might be some doubts, but that's okay. I mean, you will be understanding this with more examples probably. Okay. So this is clear, right? Okay. So here, let me just expand this till maybe infinite. Okay. Let's just expand. Let's just see what's going to happen. So this is head, tail. Now you are going to get head, tail. Here you are going to get head, tail. This is where you will stop. This is 2. This is where you will stop, but you will not stop at these two places. So let's just see this head, tail, and then you might be stopping at this. You need to stop at this, and then let's just expand this. This is head, tail. This is head, tail, and then you need to stop at this. You need to stop at this, and so on and so forth. Right? We can keep on expanding. Do anyone want to try this particular method? I mean, just try with me, okay? So here, let me write number of tosses, and let me write with what probability. So 2 tosses you need with 1 by 2 into 1 by 2, 1 by 2 square into 2 probability, right? Because these are the 2 branches that are leading to 2. For 3 also, it is leading to 2, okay? For 3, number of tosses are 3 into 1 by 2 square, 2 power cube. है ना? 2 ही ब्रांच है, राइट? 3 की भी. ठीक है. For 4 also there is 2 branches only. Okay. For 4 also, sorry, for 3 also there are 2 branches. For 4 also there are 2 branches. Okay. I think this series will not be that tough. Over 4. I think this is coming out to be easy series. So if you want to calculate the expectation, then let's just do it. So expectation will be Okay, so let's just do it. Expectation will be, you can just calculate from here. It will be 2 into, I think I can take 2 common. Okay, let me just take 2 common because it is common to all of the places. 2 common, let me just take. It is basically 2 into 1 by 2 square plus 3 into 1 by 2 cube plus 4 into 1 by 2 power 4, like this. Again, it is AGP. So what is the answer here? Let me just say this is S. So S equal to 2 into 1 by 2 square plus 3 into 1 by 2 cube, like this. And then this will be 1 by 2S will be 2 into 1 by 2 cube, like this, right? So it will be 2 into 1 by 2 square plus, if I just multiply by 1 by 2, 2 into 1 by 2 cube, 2 into 1 by 2 square plus it is 1 by 2 cube only. This should not be 2 into. Something is wrong. This is 2 into 1 by 2 square. There are 2 sequences that are leading to 1 by 2 square. Okay. 2 into 1 by 2 square plus 3 into 1 by 2 cube. Okay. And then if you multiply by 1 by 2s, it will be 2 into 1 by 2 cube plus 3 into 1 by 2 power 4, like this. This term is as it is. Why I'm getting 2 here? I don't know. Let's just solve it. Okay. This is 1 by 2s equal to, and then this is plus plus dot, and then if we just solve this is GP, you can say a upon 1 minus r. So this is 1 by 8 upon 1 minus 1 by 2, which is 1 by 2, which is basically 1 by 4, plus this is this extra term that I have, 1 by 4 plus 2 by 4, which is 3 by 4, and this is 1 by 2s, and then s will be just 3 by 2. Yeah, s is 3 by 2 we are getting. So inside this we are getting 3 by 2, and then if you multiply by 2 you will be getting 3. Okay, because s is 3 by 2. You can solve it, you are getting 3 by 2, and then if you multiply you are getting 2. So you can solve in any way, whatever way you want. I hope that if this method is clear, where you can just identify, okay, let's just solve it for E1 and E2, and then you can solve for E1 E2. Okay, then it is better. Otherwise, in this case, actually, the infinite tree is also not a bad idea. If you're not getting anything, then just try drawing the infinite tree. Basically, with these questions, I want you to make understand that if you have any such of these patterns, then you should not be afraid of these kind of questions. Now you should be more comfortable that you can draw the tree till infinite tree, or you can stop to any level of whatever you want to do. You can play around it. Okay. So now let's solve this question. We're saying number of tosses until you get head tail. So we have solved for head. We have solved for head or tail. Now let's just solve for head tail. Okay, let's just solve for this. I don't know. Let's just solve for this for head tail. So if they're saying 6, okay, may not be. Let's just see. So initially we are having nothing. We are starting like this. Now tell me what we need to do. Anyone has any idea? With the short method, not using the long method. Obviously, using the long method, you can definitely tell me. But using the short method, if you're looking for head tail, then what I should be writing here? This is, see, you will say one toss you already made plus something. One toss you already made plus something. Now you're looking for head tail, right? Okay, you're looking for head tail. Now here I think you can restart. Here you can restart, which is basically E, right? Since you can restart, it is restart. And here, this is 1 plus head tail. You're looking for tail, right? Okay, let me just assume that to be even. Okay. Basically, even is this, that you have a head in your hand And then you are looking for, let me write the event description. We have head in hand and looking for head tail. Okay. Now head, either head can come or tail can come. Now tell me, if head comes, then what will be the progress that I have made? If tail comes, then what should be the case I'm having? Yeah, this is interesting. If head comes, then what I should be writing? If tail comes, then what I should be writing? Can anyone tell me? This is little interesting. See, if tail comes, then I have got the head tail, first of all. So I think if tail comes, then it is just a one toss. No, why you are writing E1, E2 like this? Why we need anything else? I should be stopping at this point, right? If tail comes, yeah, I should be, Devananjan is right. If tail comes, I will stop at this point right away because I'm looking for head tail. If head comes, then I will be basically in the original position. I have not made any progress with respect to this E1. So I can restart with respect to E1, which means I'm looking for head tail and I already have head in my hand, which means 1 plus E1. Okay. So from here, you can get E1, which is 1 by 2 into 1 plus E1 plus 1, which is 2 plus E1. And then this is E1 equal to 1 plus E1 by 2. And then E1 you got as 2. Okay. Is everyone okay with this? E1 is 2. Now, since E1 is 2, what you can do, you can just plug in this value and then you will get this. See, I said this, that head can come or tail can come. This is start. I mean, you are not having anything in the hand. And then if head comes, then I said like, okay, this will be 1 plus E1 and here it will be 1 plus E. That's what I said earlier. See, this is 1 plus E1, this is 1 plus E. Because I'm restarting with respect to my original process, right? So here this is restart with respect to original thing. That's why I'm having E. E means that I have nothing in my hand. I mean, this is just a pure restart. I have nothing in my hand and I'm looking for head tail. Okay. And why I have written E1 here? Because I have I have head in my hand. I'm looking for head tail, and which is same as E1. So anyway, E1 is coming out to be 2. So this is 3 and this is 1 plus E. And then finally you are getting E equal to 1 by 2 into 3 plus 1 plus E. I mean, this should be clear to everyone, but let me write in two separate terms, 1 by 2 into 1 plus E. So this is 3 plus 1, 4 by 2, which is 2 plus E by 2. So you're getting E equal to 2 plus E by 2. Finally, we'll be getting E equal to 4. Okay. So if you're looking for head tail, then expected number of trials was 4. See, for head, how much you got? I think you got 6. For head tail or head, you got 3, I think. Here you're getting 4. Okay. See, the reason is that for head or tail, and for, let's suppose for head you are getting 6. It means for tail also you will getting 6, right? I mean, if you are getting head 6 for head, then obviously for tail also you will getting 6, which means you are saying that you need 6 tosses to for the head, or you need 6 tosses for the tail. Or if you're looking for one of them, maybe head or tail, then you just need 3 tosses. But if you're looking for a pattern which is basically differentiating, which means either head tail or tail head, which means either head tail or tail head, then you will be needing 4. Now, uh, let's suppose that if I ask you that for head tail or tail head, how much you will be needing? What does your intuition says? For head tail or tail head? 2, right? Because it should be the half of this. Do you want to do attention homework, or should we do it now? For, let me just write it, for head tail or tail head. Okay, we need Yeah, 4 is correct. Yes, this is correct. Okay. If you're looking for a different pattern, it is 4. If you're looking for same pattern, then maybe you need to work more hard, which means you need to get 6. I mean, you need to toss more number of times. If you're looking for bit different, if it is head tail is okay for you, then a bit lesser maybe, because you are relaxing your conditions, right? I mean, if you want the same thing, no, intuitively also it should be lesser. See, here I am saying that don't look at the with respect to the probability. Look at like this, that you want the same thing. Okay, you want the exact same thing 2 times. Then you need more effort. If you are okay with that with the pattern that head and then tail or tail or the head, then you will be getting lesser thing. Okay. So, okay, Ekta, you can work with your calculation. You are saying that you tried with one tree diagram and you are getting 6. There must be something wrong. Okay. And you can send in the group. We will check. Okay. So you just do it as an homework that for head tail or tail head, what you should be doing, or should we do here now? Suppose you start, either you get head or you get tail. Then you want head tail or tail head, right? Okay, let me call it as 1 plus E1. Let me call it 1 plus E2. Okay, you have head in the hand, and you can get head, you can get tail. So here it is 1, but here you just have head in the hand and you are looking for head tail or tail head. So what you should be writing here, this is E1. You have just one head in your hand and you're looking for head tail or tail head. Is it same as this E1 only? This is same as E1, right? It seems like same as E1. 1 plus E1 or 1 plus E2? I think 1 plus E1 only. You know? For E2 calculation, you can say you have tail in the hand and either head can come or tail can come. So if tail head, okay, this is just 1. Tail, okay, there is no progress, basically 1 plus E2. So if you just get the answer, I think E1 should be 2. We have solved these kind of patterns. I think we got E1 as 2, right? 3 plus 1, 4 by 2. Yeah, E1 is 2. So from here, you can get E1 is 2. Okay. And E2 is also 2. So this will be 3, this will be 3. And then final answer is 3. Oh, final answer you are getting 3, not 2. Okay. So one second. Okay, the final answer is coming out to be 3. Okay, it is not 2. It is coming out to be 3. Yeah, things are a bit counterintuitive, but if you work with the calculation, you can do it. So the final answer is coming out to be same as this. Okay. Anyway, like it is a bit counterintuitive because there we got 3. I mean 663. Here we are getting 443, which is same as this. So we need to actually think about it very clearly, that if you want to make some intuition out of it, but it is not worth, like for gate purpose, I think we are good. You can, as a student, you can just think about it, that why we are getting like this. Okay. Okay. So we are getting finally 3 as an answer. ठीक है, कोई problem नहीं है. See, but the important thing is that it was a completely new problem to us and we were able to solve it very quickly, right? This is important because like in the exam, they will not ask you these kind of questions. They will ask you something else if they ask, right? And if they ask something else, then you should be able to answer very quickly using these kind of pattern. Now you should not be afraid for the expectation if it is recursive expectation especially, right? Like if you are solving with those table thing, I mean if there is some question with the table thing, then obviously you should be able to do it. But if it is complicated, then they make recursive expectation recursive in the sense that expectation is expressed in terms of expectation itself. Then these kind of questions should also be clear. Okay. Okay.